Hello parents, I'm Mr. Howard Yu. Let us examine this question which appears in the school's prelim examinations in 2025. This is a very good question testing the students' understanding of how the electrical circuits work. So it says that John set up a circuit that is fixed to a box with a seesaw attached to the top where the ducts can move up and or down. The seesaw has identical plastic ducts with iron rings of different masses attached as shown. So number one, the first thing the students need to identify is there are two iron rings of different mass. On the right is a 10-gram iron ring, and on the left is half the mass, is 5-gram iron ring. Secondly, the student need to understand how this works when the circuit is closed. So if you close here, if you annotate, this is two batteries in series. The current will flow through the wire and to the coil of wires, and this will cause the iron bar to be magnetized into a temporary electromagnet. And because, as you know, iron is a magnetic object, so if the distance is near enough for the influence of the magnetic force from this iron bar to attract this 5-gram iron ring, you'll be attracted downwards. So this is, you annotate this way. And because it is linked by this seesaw, so when duct A moves downward caused by the magnetic attraction of the electromagnet, this will cause duct B to move upwards. Next, if you observe carefully or if you can visualize, as duct B move upwards, what will happen? This metal contact will have an open circuit, this part, because when duct B moves upwards, there will be a gap here. So that means the current that was actually flowing through the closed circuit here will be interrupted by this gap over here. So in other words, it will be demagnetized. So the current, it can't flow, right? So all this will be erased off and there's no current. So what will happen? So even though this is closed, right? So because 10 gram is heavier than 5 gram, so the force of gravity will cause duct B to move down naturally. So duct B, because it is 10 gram, due to the force of gravity, it will pull it back. So when it comes back, it forms a closed circuit again. And this is repeated. So it goes up and down this way. So this you need to explain. It's quite a mouthful. It's a 2-mark questions. And I show you one of my students in my training. He has answered this question quite well, but this he answered wrongly. There's another question. This another student, actually he answered quite well. Because this student, I like to show you that he makes up, because he said when the circuit is closed, duct B will be tilting downwards. It's actually upwards. So let me pause for a while. I'll show you another student. His answer is actually quite good. Okay, as I mentioned, this student actually he answered quite well. And let me ask you one question. Okay, you see when John closed the switch on the electric, close the switch, right, electric current would flow through the circuit, magnetizing the iron bar into an electromagnet, which will attract the 5-gram iron ring on duct A, and a seesaw would lift duct B up away, which is correct, from the metal contact point, which will create an open circuit, correct? That will stop the flow of electric current, demagnetizing the iron bar, and duct B would drop back onto the metal contact, creating a closed circuit, which will allow electricity to flow through and repeat again. So actually, this student, he answered quite well. But my question is, why did the school deduct him half mark? This is a mystery which I can't understand. So I leave it for the students and the teacher to solve out why was he being penalized and half mark disappeared from this question, which I let the student to discuss with the teacher. But let's continue. What could John do the circuit to make the duct move up and down faster? So he could add more coils to the wire, okay, add more coils to the wire, or he can increase one more battery in series to increase the electric current. And then this is the part where many students answered wrongly. This is the part C. Okay, I'd like to comment on this. If you see the original questions, okay, so they say John replaced the 5-gram iron ring with another 5-gram metal ring. He made sure that the metal contact touched the 10-gram iron ring. That's mean this part, right? This part changed to, instead of iron ring, changed to a metal ring, but this remained the same. So we see how this both student answered. Okay, this student, he answered, okay, he answered this manner. The magnetic force between the iron bar and the 5-gram metal ring was too strong that even when it was open circuit, the iron bar and the metal ring were attracted to each other. So he said that when you change to the 5-gram iron ring to the metal ring, this thing attracted too strong, which actually there's a slight possibility. That means the thing get stuck there. It cannot be, the 10 gram cannot lift this up. Okay, actually the solution to this question is actually the 5-gram metal ring is a magnet. Okay, why I like to comment this, because I think it's a bit unfair for the candidate because of this word here. They say it's replaced with another 5-gram metal ring. So instead of metal ring, I suggest that instead you should put with a 5-gram material. Okay, with a 5-gram material. Okay, because this material is actually is magnet according to the model answer. Okay, the other 5-gram metal ring is a magnet. That means the unlike pole. So for example here, right? If this is north, okay, when you turn on the, if you close the circuit, if this is magnetized, the north, this is south, right? So that means the unlike pole of this magnet, right, is facing this electromagnet. Okay, put a south here. This is what I mean. So this is actually what the schools is testing the student. They changed the 5-gram iron ring into a 5-gram magnet, okay, which the student actually answered correctly. The other 5-gram metal ring is a magnet. So when the circuit was closed, with electricity flowing through the circuit, the new metal ring, which is actually the magnet, is attracted to the iron bar. Even after the circuit was open, the iron bar, which is made of magnetic material, and the new ring, they say it become attached there. You see here, because it's a magnet, right? It get attracted, so it won't. That means the magnetic force of this 5-gram here is stronger than this 10 gram. That means the 10 gram it can't come down because it will come this way, right? If I draw here, so this is 10 gram, okay. But because this is a magnet, it gets stuck there, get attached. The north attract the south. Okay. So this one actually relatively good questions, but I think perhaps this word need to be changed to material instead of matter, so that students can also think of the possibility that it is a magnet. So this is quite a good questions that tests students' understanding of how the electric circuit work and how the 10 grams metal ring in part A, due to the force of gravity, will naturally come down after the circuit is open. So I like to wish you well in your coming PSLE science examination, and those who need help, you may contact me for further training. Cheers.